You failed. E for you. Okay. So we're here to get together here rather unexpectedly, are we not? Caught maybe some of you by surprise. So I don't have a schedule review, but I expect there are many questions regarding material, but especially the whole ProctorU thing and signing up and all of that terrible confusion. So I'll try to clarify how in the world you proceed from here and get exam 4 taken, plus exercise your right to retake the lowest exam in what's called the optional final. So exam 4, what happened? I don't know, but probably I'm at fault. When you go to ProctorU, it's a constant scheduling creating special exams for people who have extenuating circumstances and all the back and forth of doing that all day yesterday. Somehow the main exam got put back to 3 a.m. Friday, April the 23rd. And so I looked this morning and was beginning to get emails because somebody said, had I noticed it was the 23rd, I went, well, heck no, and I went and I changed it back. Unfortunately, 350 people had seen that it had been extended. I don't know when it got extended, but it magically happened in the night or sometime, I don't know. And so then the flood of emails, the electrons, came pouring in. I've been typing my fingers like I need to rest them. They're so, I don't fly over the keyboard. It's like hint, 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 hint. And I've been typing all morning, trying to say, I'll do whatever, please get me out of this terrible mess. So what I did was, after about 10 minutes of furious emails, I reset ProctorU back to the mistake, the 23rd, and that's how I hope it is now. But someone told me it wasn't there, so about 30 minutes ago, somebody got me in the hall and I reset it and pushed the submit, and so I hope it sticks. It will remain that. Somebody tell me if it changes from that, because that is my intention now. If you make a mistake, go with it. It's better than 1,000 emails. So now that raises a bigger problem, because if exam 4 is not until the very last minute before the world ends, how do you exercise your optional retake if you haven't taken exam 4 yet? Well, that's obviously my fault too. So here's my solution. If you want to exercise your optional retake before you have taken exam 4, you're free to do so, but of course it's going to be registered as the first take of exam 4. But if you want to retake exam 2 or 3, because you know they're low, one of those is low, you don't know what exam 4 is, but you're pretty confident you're going to do okay on 4, go ahead and do that. You may not have time to exercise your optional final if you've signed up for exam 4 the 23rd at 3 a.m. in the morning. As long as there's enough time before 3 a.m. in the morning on Friday, April the 23rd, for you to do both of those things, please try to do them both. But you realize if you wait and do your optional final first, then you really can't do exam 4 because you've already used up your optional final option. But if you wait till, let's say, Thursday morning and you take exam 4 and you go, oops, exam 4 is my lowest. I'm still fresh in that stuff. I'll just take it this afternoon. That's okay with me. Go ahead and do that. It's just, I can't extend it past 3 a.m. Friday morning because I have to get grades submitted Monday at noon. And I need a little quiet time on the weekend to sort out my life and take a long look at where I am and where I've been, where I want to go. So how do you do the live proctoring option? This is more complications. How can you do that? Dr. Gurley, you've gotten yourself into a fine fix. So I am going to offer live proctoring every day this week, starting at 7 p.m. And the last time you can come and start taking a test will be 8. So from 7 to 8, that's your window every day this week except Saturday and Friday. I go on a picnic those days. But starting Monday again, I'm right there every night, Monday, Tuesday, Wednesday, Thursday, Friday, except for Saturday and Sunday. The very next week, every night, Monday, Tuesday, Wednesday, Thursday, the 23rd, 3 a.m. That's not a night. But there'll be some people who will have extenuating circumstances for the extenuating circumstances. So I will be there Friday night, the 23rd, even though officially the exam is closed, I will have had to create a special exemption for you. So I'm trying to, and what do I do about the Proctor U fee? Was that your question?
No, it's the 23rd is this Monday.
The 23rd is this Monday?
Yeah, it is.
Who slipped me the 1848 calendar? It's really? The 23rd is a Monday?
Yes.
Isn't it a wacky world? It is such a wacky world when you just don't have a total grip on it. It can just slip right out of your hands between your fingers and go rolling down the street. But there you go, you're right. So, I've let the cat out of the bag. As you see, I was willing to go all the way to May 3rd. Something to do with 3. Something to do with 3. And so what does Proctor U think now? In their mind, they're going, okay, that Kaja changed it to the 23rd, then he changed it to the 19th, then he changed it to the 23rd. We're paying no attention to that guy. The 23rd. So all this stuff about going on in proctoring, that's just crazy. Whenever you guys want to take the exam, I'm happy to give it to you. I will proctor you live. I will proctor you in a semi-live state, whatever state you want to come. I'm the proctor for you. I want to make you a passage into reality from unreality as painless as possible. As you step out of the ivory tower into the busy street, I want you have a nice transition. Any questions? Because I got a few myself, but.
So if we take the exam for like Sunday night, and then would we have time to take the optional final later that week?
Whatever you want to do. Yeah, the optional final starts the 24th, I believe, which is a Tuesday according to the current calendar. And that was, I thought people were going all the way to the end of that, which is May 3rd at 3 a.m., which is a Friday morning, right?
Thursday.
I got my 3s wrong.
It's
Thursday morning.
Thursday morning is the 3rd?
Yes, that's the 3rd. Yeah, I know.
I did get slipped the wrong calendar. I'm working on 1848 time. Something. The registrar. That's who I'm seeing next. It just, really?
Yes, this next, not this Friday, but the following Friday is the 27th. And then the next Friday after that is the 4th.
That is so weird, isn't it? Okay, so as you see, one of us is a bit confused still. And my intention is to open it up so you can take exam 4 and exercise your option to retake any of the 4 exams. Now, exam 1's a bit tricky because it's divided into 2 parts. I would like to combine them into one. If I do that, then that creates a separate entry into Canvas, and then I have to manually, 350, decide which is the higher of the 2 grades after I add them together, which can be done if I download in Excel, and so that's actually what I should do. So I have to create a combined exam. That's not a problem for me. It's just, when will I schedule it? I'll probably schedule it, I don't know, November 23rd or something. I'll try my best to get it all straightened out. So, yeah, another question.
So the optional final, it opens on the 24th, and we have a week to take the optional final.
You have till that my intention was, the last Friday before the weekend, you have all the graduation stuff. That Friday, I think that's the 3rd, but you say it's the 4th? That's the 4th. That I will allow you to take it all the way until 3 a.m. on that last Friday. I've left myself a little cushion because there will be people who will have their reasons. So I'm trying to give you as much time on all of it as I can. If you see something that has a deadline, like an assignment I haven't had a chance to recorrect, because if I go in and recorrect it, who knows what it'll end up. Go ahead and submit. There's no penalty at all for late submission. No penalties have ever been in effect for late submission. If you can submit it, go for it. So that includes all those fantastic molecular art projects that are still in progress. I look forward to seeing that stuff. Maybe we can make like Six Flags and rides and stuff out of that. Okay, any more questions on the scheduling? I understand Proctor U has not charged some people fees when they explain the hopeless situation to them. You know, if you reschedule them back because of what I've been doing, because somebody let me near the keyboard. So I'm hoping if they have charged you a fee and you'd like for me to pay for it, I'm happy to pay for it. That's the least I can do. Just tell me where to send the check. We have a few more cameras that can be checked out. I'm hoping to get those back at the end, but we'll see. Question? The last day for the project. Well, there's really the last day and the last day that I try to set, and it wanders all over the calendar. The university has a calendar, and apparently they're sticking to it. That Friday before commencement, I think that's May 4th, is the absolute last day. I've got to grade all these things. You know, it's like, is this art as good as this art? It's in the eye of the beholder. What do I do with a piece of art that's simple but powerful versus somebody who spent days trying to figure out that confusing genome engineering project? It's the intellect versus the heart. It's centuries, thousands of millennia. It's a struggle that Homo sapien has always had. He was born with heart, just now figuring out what he should do with intellect. And apparently some of us haven't quite got the hang of it. So, how about any other questions? Like, there are slides missing that talk about RNA polymerase pausing and D-slip, and you said there were 3 ways to get D-slip recruited to the promoter. We can't find the slides. It's in the lecture. We can't find the slides. I can't find the slides either. I think I just made it up. No, actually I took it from a graduate course. Didn't realize that I hadn't gone back. And so that will not be on the exam. The downloadable PowerPoints are what you're responsible for. Also, let's see, the whole epigenetics tale with the cats and the chewing gum. That is not on there. What I'm planning to do in the future is, there's so much material in this course, I plan to start using, developing sub-modules. And for extra credit, you could take some little quizzes on epigenetics and see those instead of things that are hard for me to grade, where you could explore maybe perhaps the genetics aspect of medicine, talk about some diseases and molecular mechanisms, or plant regulation, or epigenetics, and they would be supplementary modules that would allow you to explore different interests within the course as extra credit. So I'm always thinking about how to present as much material as I can, but in a way that doesn't just knock you in the head and put you on your back and lets you explore your interest. But that'll be in the next 30 years. But I'm going to start working on that starting this summer. I'd like to pre-record more topics in a fashion that is, sort of at a high technical level, where I can integrate short video clips as I illustrate the topics. The mitochondria I'd show, the sea, the origin of the organisms and the ancient endosymbiosis. I'd get myself a drone and fly over the cornfields and talk about the transposons, the genes that are jumping underneath the wings at this very moment. All sorts of things that we could do to make this so you could actually stay awake on Thursday for 100 minutes. But, anyway, enough about me. How about a question related to the material?
So when it comes to the writing thing, on the PowerPoint, the ones that you went over in lecture, I understand, but when it comes to the drill, there are a few that I don't quite.
The TBP drill? Yeah, I just am running out of time because I'm always doing this. It was my intention, and maybe I'll get a chance, but I got people that want to meet with me after this, and then tonight I proctor. But my intention is to just go through that entire drill as I would approach every one. So you begin to see how I look at it, what I'm looking for, and how I can easily make a decision and just go through every single one for you. We could do that now, but it's useful if you kind of do it along with me and I give you a chance to think about it, then I show you how I would do it. So maybe I'll be able to do that if I quit proctoring tonight at 9. Maybe I'll have time tonight to post that. So I would post that on the module page where that, let's see, I will post it. I'm not quite sure. I'll announce where I post it. It'll be on the module page very close to where the little drill is. Whether it's a link to the homework or something, that it'll be a short little video where I go through how to do that.
Thank you. That would be.
Several people have asked me about that.
The Word document that you post for the key terms and stuff, it doesn't include some of the lectures. Do we have to worry about those lectures, or?
There are things on there like cohesin and condensin 1 and 2.
No, I mean, like, you didn't include nuclear transcription part 1.
Yeah, as I was doing this, I'm so focused on getting the last ones, I did not go back and notice that I didn't have 1. I think I looked at 1, and a lot of 1 is incorporated into the others. 1 is kind of a very general, but I realized I did not do histones and nucleosomes, and part 1 is not very well populated. I will go back. I'm running out of time here. I will go back, and it takes me a long time to do that. It looks like just a bunch of words, but I go through every slide and I looked at it and go, how much is this necessary to understand the main concepts and to do well on the exam? And I try to make it so it's a rapid guide so you can tell whether there are things you need to sort of go back and look at again. So that's my intention. It takes a while to sort of plan that. The most important things are out there. Some people are having problems with a question that deals with the new way to look at the higher order folding. So there are figures there. So be sure you've got the latest. I'm not changing PowerPoints anymore. Be sure you've got the latest version of the PowerPoint, because I went back on the chromatin one and put 3 or 4 slides in there that describe the loops within loops. So I'll review that. You have these large major loops that are attached to what eventually condenses to be the central skeleton of the mitotic chromosome. And in the figure, they are red rings. That is condensin, not cohesin, but condensin, as you condense chromosome. Condensin, Roman numeral 2. That's the major one for the major domains of 100 kilobases or more. Within those, you have sort of a series of, I guess you say, the loops are nested. And that is done by condensing 1. Condensing 1 does the loops that are within loops. Condensing 2, the red loops, are the ones that constitute part of the scaffold and make the major domain boundaries. And that is in a question bank. Some people get it, some people don't. There's a question about, don't know whether it's in the PowerPoints anymore or not. So I'm always editing, but it'll ask you something like, where does something happen? Where would you find the histone code happening? Or where would you find mediator binding? So where does mediator bind? It binds to the CTD, right? The whole hyperphosphorylation story. But if you think about it, mediator also binds to RNA polymerase. So there might be a question with 2 correct answers. I'll have to go back and manually adjust the scores so each of those answers gets credit. I can't do it automatically in Canvas. If you get that figure, you'll know it. It looks rather strange. It's got this great big looping tail CTD coming out of the back of the RNA polymerase. You'll know that's a CTD because you have various complexes bound to it, right? Another big complex, big string will come out of the RNA polymerase, and it'll be red, and everybody knows RNA is red. No, it'll have on the end a 7-methyl G. And that's an indication that's a piece of RNA, that's not the CTD. Okay. Where would you find the histone code? You try to look and find some nucleosome somewhere, if you were asked that in that figure. If you go to the PowerPoint on images, it says exam 4 images. It was added just above the bottom of the module, just above where it says exam 4. That will take you to a PowerPoint where I took images that appear on the exam in one question bank or another. So take a look at those. I have red arrows, and I'm going to be asking you not what is the red arrow pointing to, because that's way too easy, right? You'd never get confused that way. I'm going to do things like which arrow denotes the helicase used both in transcription and nucleotide excision repair. And so you're going to have to know the answer to that, and now where it's located on that stupid figure. So what is the answer to that? The one that's used in TF2H, the one that's used in both of those situations? It would be B, beta, XPB. It has the ratchet mechanism for shoving the DNA into the DNA channel of the polymerase. So it's used in transcription. And the other one, RAD3, which is XPD, delta, is there just to position the CAC. Its helicase activity, it really does not participate in transcription, but it does participate in nucleotide excision repair. So both of them participate in nucleotide excision repair, and only B participates as a helicase in transcription. Let me see. Can't think of, go ahead.
Will the TAFs be on the
That little sign flipped down and said this will not be on there. You will not need to know it in that detail, but these are some you should know. You should know which TAFs recognize the initiator. That's 1 and 2, right? 1 and 2 together recognize the initiator element or region of the core promoter. How about 6 and 9? They recognize the downstream promoter element and are also targets for acidic activators. You should know about TAF1, the fact that it has enzymatic activity, especially that it has HAT activity. HAT, histone acetyltransferase, is involved in decondensation of the chromatin. Should know what TAN1 does. Of course, TAN1 binds to TBP so that TBP does not continue to search for the TATA element in the DNA. It's already sort of masked. That allows TF2D the freedom to search promoters that have no TATA, which is most of them, right? Most promoters have no TATA. Most promoters are not strongly up and down regulated. They're either off or on, depending on the epigenetic state of the particular organ or tissue they happen to end up in. They can be shut down forever, but when they're on, they're usually just at sort of a steady, even keel, a housekeeping function. And if that's the case, they may have CPG islands for this gross level of on or off, but they're not going to have advanced features for induction or fine-tuning regulation. And so they are not going to have a TATA. But that's most genes. Most genes are taken care of by TF2D. Remember, D is the entire complex. It has TBP and the TAFs. It has 11 to 14 TAFs. At least 4 of those TAFs, the ones that form the core, which is 6 and 9, 4 and 12, and either it's 4B or 12B, I can't remember. 4B and 4B form a mimic nucleosome. They have histone folds in them. We don't understand why, but it seems like it might have something to do with wrapping DNA. Does that mean that TF2D used to be a nucleosome that got smart? It was a specialty nucleosome that learned how to direct the polymerase to the start of transcription. These are all interesting speculations. So I was answering you about the TAFs. I think so you'll need some of it, but you're not going to need to know what does TAF 4 do, gets A, you're not going to need that 9 gets B, and all that stuff.
So TAF 1 has that part that can essentially mimic the DNA and prevent TATA binding?
On the N term, it's called the TAN. There's TAN domain 1 and 2, and they both participate in that, but TAN 1's one that actually goes in the underbelly of TBP.
So if TF2D is trying to bind at a core promoter that does have a TATA, what happens then?
If TF2D does?
Yes.
Well, it probably meets fierce competition from the other co-activators that are also in the business of delivering TBP to promoters. But their TBP is perfectly capable of binding TATA. And so they're going to be in competition with something that is looking for TATA. And so it's probably not going to win. And there are transactivators that totally ignore TF2D and deliberately recruit SAGA or PCAF or P300 or CBP. So TF2D has a real disadvantage because it's not really actively being recruited to that kind of promoter. What's an example of a transactivator in yeast that specializes in SAGA, totally ignores TF2D?
GCN
4. Yeah, it's the 4 versus the 5. What is GCN5? That's the subunit of SAGA that has HAT. What's the subunit of PCAF that has HAT? PCAF. That's so hard to remember. And those other two, the P300/CBP, that's just one big protein. It has HAT. It's not part of a big complex. All of those so-called co-activators, those in that list, are able to recruit TBP to the core promoter. Not all transactivators can, but not all co-activators can attract TBP. The mediator, the tail, the up, the down position, there's a figure there that shows if you hold mediator like dripping wet and the tail is on the bottom, if the tail is like this up against, it's like what are those little sand fleas? The things you put down your little brother's swimsuit. when the surf goes away, you see them and the little turns are going out and you dig them up, you get a whole handful of them and you stick them down and he goes, oh, he calls his mom and everything. It has a very unpleasant ending for whoever does that sort of thing. It's great fun now, first couple of times. Anyway, the tail on mediator, that is the down position, that's the up position. In that diagram, it looks like it makes contact with GCN4 when it's in the up position. Like, you'd think maybe when it was in the down position. Anyway, the up and down, you will not have to tell me up or down, but know that GCN4 grabs that tail part of mediator. There's a figure there in the PowerPoints. You may have to identify things on figures like, where's the CTD? Where is TF2K? What is TF2K? If you were a yeast person, heaven forbid, that's what you would call the CAC. In yeast, it's been considered a separate, independent basal transcription factor. In other systems, it's more tightly associated with H and is thought of as a submodule of H. It's the same proteins with various degrees of association with H. In fact, in higher organisms, in us, the CAC, about 70% of it doesn't even associate with TF2H. It regulates cell cycle all on its own. It's a kinase after all. Cycle-independent kinase, CDK. What's an amphipathic helix?
One that has both hydrophobic residues and hydrophilic residues.
And they are distributed on opposite helical faces. So if you have the helix on one surface, it'll be hydrophilic, the other surface hydrophobic. Hydrophilic represented by either plus or minus charges. It's usually the same charge, so it doesn't collapse on itself. So most of them are a series of negative charges, so it's been called an acidic activator. And it has no firm protein helical structure unless it's in contact with its recruitment target site. What is topless? It's that plant transcription factor that serves a co-repressor role. It recruits HDAC and is connected, usually not directly but sometimes, to a DNA binding domain through one or more proteins that can be degraded and in response to various hormones in plants. So it's a co-repressor in plants that it's attached. The DNA binding domain can be an activator or a repressor, depending on whether topless is connected to it or not. If topless is connected to it, it's functionally a repressor at that point. If that bridge is loosened or cut, then topless floats away and it becomes an activator. How about the steroid response? That's certainly pretty main core exam stuff. You know about the SMART complex. You know, the thyroid receptor is the thyroid receptor in complex with the 9-cis-retinoic acid form a heterodimer. In fact, that whole class on that slide that has the 1 and the 2 and it has the direct arrows, and that slide is good to know. The estrogen, and androgen, mineralocorticoid, glucocorticoid, progesterone, the typical steroids, as you've learned them, are in that first category, and they are recognizing an inverted repeat, each monomer to make the dimer. It's bound to 1/2 of that. It's exactly the same sequence. in the repeat, except for one, except for the ER. And the specificity depends on the spacing between the two repeats. In that second category, where the weirdos are, which is the retinoic acid, 9-cis retinoic acid, vitamin D, and thyroid, they're in that group, and only one of them can bind as a homodimer. The others have to be in complex with 9-cis retinoic acid. But when the thyroid receptor is in complex with 9-cis retinoic acid, it's always in the nucleus. It doesn't have this nuclear localization strategy for regulation. It just automatically goes to the nucleus. And so that's why it has to have a special mechanism in place to keep it from always activating its target genes. That's why it's pre-bound before the thyroid hormone gets to it. It's pre-bound to the co-repressor called SMART, S-M-R-T. So binding the ligand now makes the thyroid repressor lose affinity for the co-repressor, and now you have that normal cascade of events where you recruit, where you hit the swing helix, helix 12, it swings out of position when you bind estrogen, in this case the thyroid receptor, the helix 12 swings this way and it opens up this binding pocket for P160. P160 is a coactivator. It has HAT activity. And it in turn recruits other coactivators, other complexes that also have additional HAT activities. So P160 is allowed to bind by that helix 12 swinging out and unmasking its binding pocket. And it in turn recruits a variety of coactivators, including PCAF, which can bring TBP. It sometimes recruits CBP, sometimes P300. All of these other ones contain HAT and additionally can bring TBP to the core promoter. And once TBP has arrived, P160 continues to evolve in its function. It is methylated on an arginine that causes it to lose affinity for these wonderful coactivators it just recruited. But it's just used them to get TBP there. Once TBP is in place, now the other coactivators leave, and now P160 is recruiting mediator, and mediator arrives on the scene. Can't think of anything else.
In the study guide, you have a question that says, which large vasotranscription factor will you capture within the affinity column comprised of synthetic CTD?
Okay, so you have a synthetic CTD. You can synthesize that, you can order it. It's just 7 amino acids, many of which are serine and threonine, some proline. And it's what's found in the carboxycarbonyl domain of RNA polymerase 2 in eukaryotes. Okay, so you think what interacts with that? Or, so that's one thing you could use. You could recruit, using that as an affinity column, you could recruit mediator. Remember this hypophosphorylation versus hyperphosphorylation. When you get it synthesized, just get it synthesized without being phosphorylated. It's going to bind, have affinity for mediator. Another way to get, using an affinity column to attract mediator, is to use a strong transcriptional activation domain, because some of these recruit mediator directly also, and the best one to use is the strongest in the world so far we know about. It's viral protein 16, or VP16. And it has 2 alpha amphipathic helices. It's a very strong acidic activator. You can activate transcription in lots of eukaryotic organisms, including plants. So now it's getting a little bit dated. There's a model that looks like a big Dutch shoe or a big fat blobby kind of banana or something, and it has kind of two configurations, open and more compact. That is supposed to describe the way that mediator can regulate or control the amplitude of transcription, how strong the transcription is, and it's really controlling the ease at which reinitiation can occur. If it's in the wrong configuration, it's hard for the RNA polymerase to get situated in this close contact with mediator, so reinitiation doesn't happen as frequently, so you don't have as much activity from the promoter. And so if the mediator has several configurations, and that model may or may not hold up in the next 5 years, but if it has several configurations, then it begs the question, well, if mediator is controlling it, but there must be something controlling mediator, what determines the different conformations? If that's where the control is, and it's who brings it to the party, which transactivator grabs it. So one transactivator could grab it, by the arm, and it would end up in this conformation, or another one could grab it by the back, and it would come like that on its tiptoes. So you can see the point of contact by a transactivator may change its conformation, that's the theory, and lock it into one mode of activity. Very active, medium activity, low activity. That's the theory. And it's based on a few experiments where you can recruit with a couple of different transactivators and look under EM, and you'll see different conformations. So that those observations have led to that simple model of how it can control the amplitude of activity. I would say there's still a lot we don't know. Another question? Oh, I think there's a homework question that's it contradicts the notes. It's about CDT13, which two proteins are recruited at the telomere. One is STN1, which keeps the 5' end from being digested too far. And the second one is telomerase, or depending on the notes or the homework, it's TFR2, I think, part of the sheltering complex. So I looked it up, and actually it's neither. It's a protein called TN1, and I decided that that's just crazy. You don't need to know that. That's not going to be on the exam. I'm going to have to remove that question from the homework, just haven't had time. What's a T-loop? It's where the end of the chromosomes are tucked back into itself. So there's really no end. It's just a loop, like somebody spliced the end back into itself. So like a Rec-A kind of thing. The TRF2 sort of mediates that operation. But what is RAP1, SR3, SR4? Remember those? RAP1 binds the telomere sequence itself. It's a protein that binds to that repeat. And then it recruits SIR3 and SIR4. And they make connections to the histone 3 and 4 tails. And they make connections, one of them, SIR3, to the nuclear matrix. So SIR3 actually has buried within it a domain that closely resembles a protein that's already in the nuclear matrix called lamin. So it has a lamin-like domain in it, so it kind of melts into the nuclear matrix as if it was just another lamin. What's an insulator? Remember the heat shock? We had these SSC 1 and 2. They define the boundaries of influence between adjacent promoters. You put an insulator sequence, and one enhancer cannot affect a promoter that's nearby because it's blocked. And it's thought that these are really sites that form these big loops. So if you loop a domain together, you restrict its interactions. So you can get things that are far apart, but it's going to be restricted to things, to elements and proteins and nucleosomes within its same big DNA loop, not over there someplace. What's a lamp brush chromosome? Where would you go looking for one? You probably in my closet you could find some, but it's amphibians, newts. Why newts? Who knows? But they have this long, 6-month long prophase in meiosis and formation of the gametes. And so it's so drawn out that the cell has to respire and to carry on the activities of life. So you have this, it's caught in between two needs. It needs to divide and make sure the genome is replicated and divides equally distributed among the two daughter cells. So that requires condensation of the chromosome, yet when you condense the chromosome, that works against transcription, expression of all of these genes to make the proteins and enzymes that you need to respire and live. And so you see this compromise situation where you have big DNA loops. And that was giving us the first clues about how things are organized. We thought we'd find much more, but it looks like it's nothing but loops. Loops, and then the loops have nested loops. Well, that's what it's like this spring. Who knows what it'll be like in the summer? How truth is still a bit slippery. This is what we see through the glass darkly at the moment. That didn't mean to go profound on you. Another question? I'm trying to think then. It's been so long since I took exam 4. So the TBP binding, right, the TBP is definitely going to be that. DNA binding domains, you'll be asked, you know that drill, that homework drill, you'll get one. You don't know which one, so you got to know them all. Just hate that. I mean, I'm not really doing you any favors. I only give you one, but it could be the only one you don't know. Life is so unfair. See, the time is 100 minutes instead of 120. And the optional final, the times will be 90 minutes. So far, the average time on exam 4 has been about 30 minutes. So I'm still giving you 3 times what you're probably going to need. So I'm trying to eliminate the funny business that sometimes goes on with staring at the screen too long. Where to position the external camera. I've noticed that the ProctorU person got the instructions wrong for the up till now. So I've gone back and switched it where I say the camera needs to be at 90 degrees from the test taker. So to your side. What I want to see is not your eyes. I've seen your eyes for 3 exams. I know your eyes. They're furtive and guarded, and there's a furrowed brow a lot of the time. And there's a lot of playing with your fingers and doing all sort of displacement kind of stuff. One guy was flipping a coin for a while. You could see him there, and you're looking into his desperate eyes, and he's going, and that wasn't working. So he pulled out a rosary and started going through the beads. I don't know. It's really, I don't like looking at that stuff. But I found it's my passion. It's horrible. So try to be patient with these proctors. What I want to see is the side of your face, just see where you're looking. I don't need to see the details of your screen just to make sure you're not having ads from JCPenney's and buying cars and stuff. I want to see where your hands are on the keyboard. If I see all that, there's not much I don't know about you. But I don't need to see exactly where your eyes are, because usually Proctor U will fix it. So that's all I can see. And who knows what you do? You could be juggling fire sticks below. I don't know what you're doing. Yeah, I found that most of the honor code violations involve low tech. Apparently in computer science, there's more of the high tech stuff, but a lot of just the old couple of people in the same room kind of stuff. Getting fairly good success rate this year in stopping that, but not perfect. What else? The molecular art, I prefer something that you built a 3D model, because you learn more, you get a better appreciation of your own insignificance in the art world. As you try to make something with your hands, you go, no, it looks so easy, but I can't make anything work here. I've got to show this, take pictures of it. Do I have to sign this thing? Yeah, I want to see it. Make something. There are lots of little kitty dough packages, colored doughs and stuff for fairly cheap. You make it and you can put it in the oven, put it in your roommate's toaster or something. He goes, what is this? Lots of things you can do to freak out those around you. Uh-oh, it's gotten worse. He's taking a bad turn. Look what he's doing. Shan Mugen always looks at me and going, oh, I don't want to see any more. Yeah. Right. Okay, the question was about the elements in the core promoter of RNA polymerase II. A couple of slides there, and what you'll see is there are, in a higher eukaryote versus archaea, there are, especially in animals, a possibility of having 3 elements, but only 2 at any one time, and one of them there all the time. So you can have you always have an initiator region, which is kind of a loose consensus that surrounds the actual start site of transcription. You remember the TF2B, the B reader helix, actually makes contact at -8 of the initiator region. So those sequences right around +1 initiator region are going to be there always. And then you can have an element that's actually downstream into the transcribed region, sort of like tRNA, maybe 50 bases downstream, that's predominantly found in insects, but appears in some human genes too, called the downstream promoter element. That's unusual, have an element downstream of the start of transcription. And so it'll have an initiator and a DPE, but it won't have a TATA. Or it'll have an initiator and a TATA, but won't have a downstream promoter element. And so that's defined as the core promoter. Core meaning where the pre-initiation complex nucleates and assembles. If it has a TATA, it's probably not going to have a DPE. Right, now just think about it. If it has a TATA, it's going to be recruiting SAGA or PCAF. And it's not going to have TAF 1 and 2 to recognize. Now, 6 and 9, you know, but it may have 6 and 9, but anyway, you have a different collection of subunits depending on whether it has a TATA or not. The direction of transcription, are there simple rules when you're looking at those things that you want to, look, I'm almost a grown person here. As a matter of fact, I am grown, and I'm looking at this stupid stuff, standing on my head. It's way too late for this. That question, I'll just write it off. There's some who say that, and the others go, yes, obviously transcription's coming right at me. Whoa. So you're looking for the C-terminal stirrup, because you're looking for a place to rest that tired left foot. So you can put it in the stirrup and have a seat. So there are two ways to recognize the left stirrup, and that's, look on TBP where the two ends are. But a lot of times it's hard to see those ends depending on the orientation. So the easy way is let TF2B do the looking for you. TF2B will always be stuck right on the C-terminal stirrup. It's, the two pieces of the puzzle have been put together for you. There's usually the green blob. But it's blob, it's two blobs of helices. It's not this beautiful symmetrical saddle. It has this nice beta sheet, goes across the top, and a helix here, and a helix here, and stirrups that come down. You should learn to recognize that. But so you see that, and then you look for the blob. The blob's going to be on the C-terminal stirrup. That's where you're going to put your left foot. And once you put your left foot there, the other problem is, you could put your left foot in there two ways. You could sit in the saddle and put your left foot there, or you could go the other way around but be on the bottom of the molecule, but you wouldn't have any place to sit. So those two contact points, your foot, left foot where B is, and the other is you have to be sitting down on the top of the red thing of TBP. So really 2 points of contact determine which way you're facing. And then you just look out, see what's out there. If the thing's upside down, some people in the head, just like, especially if the DNA is coming to you or going into the board, then if the TBP is on the bottom, just in your head, rotate it so it's on top. And see now, if you sat on it, which way you'd be looking, this way or that way. So that's how I approach it. Okay, I don't think there are any more questions. The average last night when I was looking at it was 88. But usually the early takers are the best prepared. So in general, I find that the performance on exam 4 is about like the rest of them. So that gives you an idea. It's not going to be especially easy. A couple of people have made 100s already, but it's possible to make 100. But it's about like the others. Depending on who you are, that could be good or bad. Mostly bad, right? Okay, that's all I have. And good luck. It's been fun, as always, and I hope you have a good ever after. And I used to say, and may your TBP always find its ta-ta. But I won't say that.